The ML workflow. Developing a machine learning solution isn't just about picking an algorithm. It's a structured process. Think of it as a pipeline or a life cycle. Understanding this ML workflow is vital for any successful project. Let's break it down into key stages. It all begins with problem definition and data collection. What problem are we trying to solve? Is it predicting customer churn, identifying defects, or something else? Once the problem is clear, we gather the relevant data. This could be from databases, APIs, web scraping, or even sensors. Next comes data preprocessing and exploration. Raw data is rarely perfect. It's messy, incomplete, and often contains errors. We need to clean it, handle missing values, transform it, and explore its characteristics to understand relationships and identify potential issues. This stage often takes the most time. Feature engineering is a crucial, often artistic step. This is where we create new, more informative variables, features, from existing ones. For example, from a date column, we might derive day of week, month, or is holiday. Well-engineered features can significantly boost model performance. Now, the exciting part, model selection and training. Based on our problem and data, we choose an appropriate ML algorithm, perhaps a decision tree, a linear regression model, or neural network. We then feed our pre-processed data into the model to train it, allowing it to learn patterns and relationships. This involves splitting our data into training and validation sets. Model evaluation and tuning follows. After training, we evaluate how well our model performs on unseen data, using appropriate metrics. If performance isn't optimal, we fine-tune the model's parameters or hyperparameters, or even go back to earlier steps to refine features or collect more data. It's an iterative process. Finally, if our model meets performance criteria, we move to deployment and monitoring. This means integrating the model into a live system where it can make real-time predictions or decisions. And the job doesn't end there. We continuously monitor its performance in the real world, as data distributions can change over time, leading to model drift. This cyclical process ensures our AI solutions remain effective.